Okay, in this video now, what we're going to do is we're going to finally play with talking to an LLM. In the last video, we learned how to work with MongoDB to do those vector embeddings. And that's going to be a big part of what we need to do in almost any AI project. And by the time we're done, you're going to see the vector database and the LLMs all sort of come together. But before we can do anything like these RAG apps, we've got to learn how to at least talk to an LLM, send a prompt to an LLM, get it to sort of do our bidding, right? We got to do that. So in this next example here, we're going to walk through turning on OLAMA, which is a model server that we can run locally. OLAMA has a set of models out there that we can use. You can't just use any model that you want. It would have to be already transformed to be able to run in OLAMA, but OLAMA's got a website. I'll show you that in a second. We'll use one of the models from OLAMA. We'll run it locally, and then we'll talk to it using LangChain Go. And we'll get a general sense now of how to talk to an LLM, at least in Go. And all these model servers have straight up HTTP APIs. That's kind of what their real interface is. So even if you're not using Go, it doesn't matter, right? You can use the HTTP client directly if you want. All right, let's take a look a little bit now at the OLAMA ecosystem. We'll get it running locally, and we'll run some code against it. Okay, so if I go to OLAMA here, there it is right there. Fairly simple website. And I really love OLAMA because, you know, if you're going to be using models out in the cloud, you're going to be paying every time you make a request to it. You either pay by tokens going in and out, or I don't know, however they're going to charge you. So OLAMA is kind of cool because it lets you do a bulk of your development leveraging your local machine. You're not going to use OLAMA for your production system. Eventually, you're going to have to spend a little money to do that. I work with Prediction Guard. I'll bring Prediction Guard up. So I work with Prediction Guard, and what's nice about Prediction Guard is they have out their model servers that I can talk to, but what's nice about developing against Prediction Guard is that when I'm ready to go into production, if I really need the privacy and the security and the compliance of a system, I get it from them, right? So the idea is that if I'm using Google, let's say I'm going to talk to Gemini, then I'm sending all of my data, everything you're going to see us do today, goes to Google. I don't know what they're doing with that. I don't care what their privacy policy says. I'm sending them data. Maybe they're taking it and using it to train some other models. Maybe Facebook is doing that too, right? But with like a company like Prediction Guard, you can start off on a shared system, and then you can get your own private system, and you don't have to change anything to sort of do that. Plus, I promise you, they're not taking any data that's going into the system and using it to train anything. I know because I work on the platform. And so I really love Prediction Guard for all of that. But at some point, right, you're not ready yet to pay. You're playing around with prompts. You're doing things. You don't want to pay to play is kind of the way I think about it. So while you're still playing and learning, I think OLAMA is a really cool way to go. And you can see here, you can search for models here, but I'll just click on this models list right there. And if I open it up a little bit more here, you can see the different llamas. So they've got the latest 3.2 model here now as well. There it is. And I got to see what I have preloaded already on my machine. I've been playing with the 3.1, but these models are fairly big. However, you can see here, right, 1 billion, 3 billion, 70 billion. I wouldn't try to run, unless you've got some real hardware on your laptop, anything that's like 405 billion parameter sizes. I think 70 billion is about as high as I would go. And this is an M2. It's got a bunch of memory in it, and it can just barely handle that. So again, we're using OLAMA because we want to play and iterate sort of for free. And then when we feel like we've got something really working, we can then go to a system like Prediction Guard and then tweak it a little bit more with production level models that are going to have you know, the largest amount of parameter sizes and things. But for a lot of the work that you do, these smaller models are good enough to play and learn before you have to sort of pay. I install OLAMA using Brew. And I already, before we started this video, I had already gone into Brew and did a Brew update. So I think, yeah, so like a Brew install. So you can go ahead and do that if you use Brew. If not, I'm sure there's other ways to install it. And then to run OLAMA, you can just say OLAMA serve. I'm going to run this make command out of our make file. Now, I was playing with OLAMA in Docker at one point, but then I soon realized that when I was running in Docker, OLAMA couldn't access the GPU on the machine. Now, maybe that was a Docker setting I was missing. I don't know. So I now run OLAMA natively. And you can see this environment variable lets me point to where I want the models located. So I've got the models that we're using sort of located within the scope of this project. I keep a lot of that kind of stuff in a folder that I call Zarf. You just got to remember to do the git ignore. You don't want to be pushing this stuff to sort of a repo. You can see here, actually, it looks like I do have the Llama 3.2 model downloaded already, but I'll show you how you can even check that without looking at disk here. So what I'm going to do is I'm going to bring up OLAMA real quick now. Make OLAMA up. Now, that's going to keep a log going there. So let me open up another window here. So I've now got my OLAMA running. It's pointing to that local directory. And if I do OLAMA list, you can see all of the models that I've sort of downloaded over time. And it looks like I did download the Llama 3.2 latest. So we can play with that one if we want. Now, it's a fairly small one. So my guess is that I have the Llama 3 170 billion. You can see that's 40 gig in size. If we go back to the Llama 2, there's a 1 billion and a 3 billion. And I think the latest is the 3 billion. If you read the tags here, you can always do a tag, right? Like :1 billion or :3 billion. But I think latest is always attached to, I don't know. I'm not seeing it off the top of my head. But let's play with the 3.2. It will be small, and I think it will be fast. We'll just change some of our code. But you can see that. So I essentially right now have OLAMA running. I've got access to all of these models. And essentially to download a model, you can do an OLAMA pull. So when I do OLAMA pull, I can specify it, and it goes into that directory on disk. And then you have that model available to you at any given time. Okay, so let's play with this OLAMA 3.2, and let's take a look at some Go code now. And I'm going to open up the example 5 file here. All right, so if we look here, we've got our main, we've got our run like you've seen, and then I've got a question, a function I call question response. Now, you can see here when I call OLAMA new, we're using the OLAMA API that comes out of LangChain Go. So this project's done a lot of cool stuff because I could go, again, straight HTTP, but I'm not doing that. I'm going to use LangChain Go here. A lot of great engineering's been done there. And they have a package called OLAMA that already knows how to talk to that OLAMA server that we've got running locally. And so we could say OLAMA new, and then we can say with which model. I'm going to switch this to 3.2. I'm going to say, let's use the latest 3.2 model that we have access to through OLAMA. And now that gives me an OLAMA, an LLM, pointed to an LLM object, which gives us the ability to do some stuff here. Now, ideally, what I really want to do is I want to use this function that's called call. And what call does is it lets us send a prompt and then some options to that OLAMA server. Now, a prompt for us is going to be a set of instructions in English asking the LLM to do our bidding, right? And when we talk about prompt engineering, it's really about knowing what to say and when to say it. It's been my experience that if we try to ask the LLM to do too much at any given time, it's not going to be as effective as if we ask it to do little things at a time. And so this idea of a chat might be that for you to get the final result you want, you might have to ask it several questions, one after the other, maintaining that, sending the old history to the LLM to finally sort of get to you where you want. So ideally, when we talk about playing, and again, I don't want to pay to play, it's about trying to figure out, let me ask it to do this, and then when I get the response, I'm gonna ask it to do this based on its response, and I'm gonna ask it to do this. And maybe by the fourth, I'm gonna ask it to do this. I get the actual answer that I want. Now, we're just gonna sort of do this one time. We're also gonna play with this idea of RAG, which means that I'm gonna feed the LLM extra content that it doesn't have, and I'm gonna ask it to operate against the extra content. So look at this code here on line 52. Here's a prompt. Again, it doesn't look like programming, right? Because it's really more trying to give the LLM a set of instructions that it can follow. And so look what I'm going to say here. Use the following pieces of information to answer the user's question. And if you don't know the answer, just say you don't know. Now, if you do some research out there, or you have the opportunity to talk to some data scientists that have been sort of trained in this space. They have lots of sort of different ways to begin these prompts. And so find those people and talk to those people and see what's being effective. When we talk about that prompt engineering, it's really about trying to understand. And by the way, this is at a model level. So one of the hardest things I've experienced is I've got a prompt that's working for model X. I now decide I want to try to play with the upgraded version of that model Y, and then my prompts aren't as effective as they were with X to Y, especially if you're trying different models from different companies. So just be aware that you might spend all this time tweaking this prompt to get the model to do exactly what you want, but it doesn't mean that this prompt is going to be effective with a different model. I just experienced that with the Connect 4 game, where I wanted to upgrade to this newer model, and then I had to change these prompts because it wasn't behaving exactly the same way. That's a little frustrating, right? But it's part of that sort of game that you have to play trying to tweak this. So here's just an introduction. Use the following pieces of information, and then what we're going to do is sort of label that information. And I found if we use these sort of labels with the colon, like here's some context, and here's the question, these prompts can interpret that and understand that. Now, each sort of model server has their own sort of syntax. What's nice about using these APIs like Prediction Guard is they do the actual sort of prompt syntax for you. They'll wrap a lot of what you send within the scope of those prompt syntaxes, so you don't have to deal with it. And they all give you a raw endpoint too, where if you want to do your own sort of prompt syntax, you can. But to get started, we don't want to do that. We just want to send this information and get. So this can get a little bit more complex, but a lot of times we don't need it to be. So you can see that the context is down here in this variable. I'm giving it a paragraph of information from my Go notebook, okay? So here's like so many words, I don't even know how many words this is, but so one block of information from my notebook, right? The intended audience for the book. And then my question is there value in the book and why? And the point here is I'm trying to tell the LLM, given this context, answer this question, right? Answer the question and provide additional helpful information, but be concise. So what I'm trying to say here is if I say provide additional helpful information, then I'm asking it to dig in to its large database of content and extend what I'm asking. Now, a lot of times if I'm doing this RAG stuff, I probably won't do that. I might tell the LLM, hey, I don't want you pulling anything out of your, say, content. I only want you to answer a question based on the content that I give you. right? That way, maybe there isn't any extra bias, or I'm not extending something. So you have to decide in these sorts of situations where you're giving a content, do I want it to only focus on the content that I'm giving it and nothing more? Or is it allowed to provide additional help? In this case, I'm saying answer the question and provide additional help, but be concise. Now, this be concise is interesting because up until recently, when I've told the LLMs to be concise, they have been. They've been giving me back maybe 1 or 2 sentences. I just switched to a new model, a new one that Prediction Guard hosts, that they felt like was the best model that they have out there for chat, and it's not listening to be concise. So like I said, every time you get a new model, they can behave a little differently. And then I'm saying responses should be properly formatted and easy to read. So again, this is just me playing with an initial prompt, right? I honestly don't know if the LLM is listening to that or not, or how it interprets that. And this is where I might go to a data science friend when I'm not getting the results that I want and say, hey, what better language should I be using? What order should I put this in? Am I asking it to do too much too soon? Which has usually been my biggest problem. Asking to do too much too soon. So as a general guideline, try to ask the LLM to do one thing at a time. Be as precise as possible. You can always send its result back on the next sort of query, and then ask it to do one more thing, one thing at a time, one thing at a time. So this is basically one thing at a time, right? Take this context, answer this question. You can provide additional help, be concise, and just make sure everything is easy to read. Now, by default, I have found that everything's usually easy to read. So maybe, asking it to do that here is irrelevant. But again, that's part of playing with it. Okay, so what we're going to do is we're going to try the Llama 3.2 model. We're going to use this prompt. We're going to fill in those %S's with our content and our question. Our content is about the intended audience for my book. And another thing we're going to be doing is using the streaming API. Now, what the streaming API does is it sends the response, usually 1 token at a time, and that token tends to be a word. So, and that's what's going to give us that sort of, it looks like that the LLM is talking to us. So you can make a call and wait for the entire response, but with streaming, you can start to get the response a little quicker, and it makes the experience of talking to the LLM a little bit more dynamic, or maybe human, all right? So what we're doing here is we're going to say with this streaming function F, and essentially every time a chunk comes back from the LLM, which in our case is really going to be a word, we're just going to display that using the print right there, printf, okay, just print. In fact, I don't even need the %s if you really consider. I could just do a print with the chunk. I don't know why I did that, but we're not going to touch that. But we are going to validate that we haven't timed out. I don't think I'm using a context with a context. Okay, so I do have a 240-second timeout on this. That's fair. Make sure that your timeouts are fairly large, especially if you're running OLAMA locally, because it's not going to be as fast as, say, a production model out there in the cloud. And the last thing you want to be doing is it failing and your code is right, you just didn't give it enough time. I just also make sure that we do have a chunk there. And if the moment that we get back a non-chunk, it looks like I'm saying that we're done. So it looks like this will keep calling it until eventually it gives us a length of 0 byte chunk, and then we're done. Okay, and then we're just using our wait group to wait, and we should see the result here. Pretty good. Now, I'm sure in the make file, I have a example 5. There it is right there. So we're going to run that. We've seen the code. I've got OLAMA running here. So let's do it. Let's do a make example 5. We saw a bunch of logging going on the OLAMA side. And boom, there it is. And now we get that sort of experience where we got back that chunk at a time. Now, remember, I gave it the information related to the intended audience, and I asked if there's any value in the book and why. And it turned around and said, yes, there's value in this book because it provides a comprehensive reference for the Ultimate Go class, right? And it looks like it also gave me some extra information, additional help, right? While the book is not a beginner Go book, it's designed. And so it came up with this answer, not necessarily on its own. It's leveraging this content, right, to produce this sort of result. And again, there's no intelligence here. The LLM isn't intelligent. It's just really good at autocomplete. It's really good at going, if the next word is value, what should, right? If the current word is comprehensive, what is the best next word related also to the content that I have provided? It looks like it's intelligent. It feels intelligent. It isn't. It's just really good at pretending, which is amazing. But look, with this little program now, we know how to create a prompt. We know how to give it extended information. We know how to ask the LLM a question, and we know how to submit that to our model using OLAMA. Now, what this is going to do for us is now that we've got the vector database piece in place and we have our ability to talk to the LLM, we can actually do something super real. What we could do is take my entire Go notebook, chunk it up like you saw one chunk here, chunk it up into small pieces. We could vectorize each piece and put that in Mongo. Then ask a question, find the most similar chunk based on that question, then feed that chunk to the LLM and have the LLM give us a response and make this system look incredibly intelligent and powerful. And that's what we're going to do in the next two videos. We're going to take the Go notebook and vectorize the entire thing. That's going to be video 6. And then in video 7, we're going to build a little chat app specific to the book where we can ask it questions about anything in the book and get a very intelligent, again, it's fake, but intelligent response back. So we've got all of the building blocks now, our ability to do that. So take a break, go get something to drink, then let's turn on video number 6, and we'll start to build our really simple but powerful Ultimate Go Notebook chat app.